In section 5.3, we're going to explore the tangent function. And to do that, we're going to look at Desmos, and then a little activity here. And you can see on the left-hand side, we have a number of different functions entered into Desmos. The first one is sine x, and if we look at our sine x graph, it starts at the origin and goes up to an amplitude of 1 and down to a -1. And again, notice the points, that's 3 pi over 2. Here it's pi. There's pi over 2 and 0. And this one cycle is 2 pi. Similarly, if I take a look at the cos graph, same thing. Cos is an x-intercept of pi over 2. Then it goes down to -1. 3 pi over 2, then it's back up there. And again, those are the 5 main points for cosine. Now, if we take our sine curve and divide it by a cos curve, we found out earlier that sine divided by cos is tangent. So this is what that graph looks like. So I'll just get rid of these two, and there is the graph of tangent. Now, going from 0 all the way to this x-intercept right here, which is pi, this distance is 1 period for a tangent graph. So tangent, its basic graph only has a period of pi, not 2 pi. And that's the major difference between sine and cos. Again, if we look at the graph of tangent, you can see that's the same thing because the black line is on top of the green line. And negative tangent, if I take these two off, negative tangent is the same thing except it goes downwards first. So instead of heading up here, negative tan goes down first and then it goes up. Now in the middle, you don't see it, but there's actually a vertical asymptote there, and we'll look at that when we draw the graph of tangent in the next slide. Okay, let's, how do we draw tan x? Okay, well tan x, again, we look at the characteristics. First of all, the amplitude. Well, for tangent, the amplitude is always undefined, so we use an infinity symbol. The period for tangent, the formula is pi over b, and there's a 1 in front of the x, so the period is just pi. Again, for tangent, we do the critical numbers, just like we did before. And for our critical numbers for tangent, we're always going to start at 0, because we're not going to be doing a horizontal and a vertical phase shift for tangent. So we start at 0, and then I take the period and times it by 1/4. So that means I'm adding pi by 4. So I get 1 pi by 4, 2 pi by 4, 3 pi by 4, and 4 pi by 4, which is really pi. So I'm going to put those markings on my x-axis. So there's 0, pi by 4, pi, or 2 pi by 4, sorry, 3 pi by 4, and 4 pi over 4, which is pi. I guess we could probably change this guy here to be, if I can get my eraser to work, let's just renumber these here. Reduce form. So pi by 4, pi by 2, 3 pi by 4, and pi. Now for tangent, the first point, which is 0, and the last point, which is pi, will be on your horizontal axes. Your middle critical number is going to be your vertical asymptote. And we should note that a is equal to 1 in this case, because the number in front of tangent x is 1. So what that tells us, that's kind of our stretch factor for our tan graph. So at these midpoints of pi over 4 and 3 pi over 4, at pi over 4, I'm going to have a value of 1, because a is 1. And at 3 pi over 4, I'm going to have a value of -1. So my tangent graph is going to start here. It's going to go through that point and curl up towards that asymptote. This one's going to start here and go down towards that asymptote. And that's your basic graph for tangent. Again, there's a look at it on Desmos if I just cut off the window from 0 to pi. And there are some characteristics for the tan function. There are no max and mins. The period is pi. The y-intercept is 0. And you can read through the other ones, but we're just going to sketch some basic tan graphs that have a different a and b value. So we want to graph the function y equals 2 tan x. So again, my amplitude is going to be undefined. But note the a value is 2. The period is going to be equal to pi over b, and b in this case is 1, so the period again is just pi. And for my critical numbers, again for tangent, we start at 0, take the period and divide it by 4, and I'm adding 1/4 of a pi. So these are going to be the exact same as they were for the last one because b is 1. So 0, pi by 4, pi by 2, 3 pi by 4, and pi. Again, the middle one is our vertical asymptote. Again, my graph is going to be here and here. It is positive, so it's going to go up. But now, because a is 2, my stretch factor is going to be 2. So that means that pi over 4, the point halfway between 0 and pi by 2, it's going to go up to 2, and at 3 pi by 4, it's going to go down to 2. And now when I sketch this, it's going to start here, it's going to go through that point and head up, and this one's going to go down through that point and head down toward the vertical asymptote. So it looks very similar. The only difference is my stretch value is 2 now. Okay, let's try one more. And in this one, we have, actually we have 2 more. We have, again, my amplitude is undefined, but a is equal to 2. The period is going to equal pi over 3. So to find my critical numbers again, we start at 0. We take the period, which is pi by 3, and times it by 1/4, which is going to be pi by 12. So it's going to be pi by 12, 2 pi by 12, 3 pi by 12, and 4 pi by 12. So I'm going to list those on my x-axis. So 0, pi by 12, this would be reduced to pi by 6, this would be pi by 4, and this would be pi by 3. And again, last critical number to the first critical number, if I subtract those two, I should get the period. Okay, when I graph this one again, I'm starting there and there. My middle is my asymptote line. A is 2 again. So my stretch factor is 2. And that pi over 4, it's going to be -2. And again, my graph's going to go up like that, and down like that. And that would be your tangent graph for y equals 2 tan 3x. Okay, the last one. Again, amplitude is undefined, but a in this case is -3. The period is going to be pi over 1/2. So if I multiply by the reciprocal, the period is 2 pi. And this time, for my critical numbers, I start with 0 again. I take the period, which is 2 pi, and times by 1/4 or divide by 4. So I'm really going up by pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And again, if I write those in reduced form, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Again, the middle guy is going to act as the asymptote. There are my zeros. This time my stretch value is going to be 3. Now the only difference is a is negative, so the first one is going to go down, and the second one is going to go up. So my graph will come down through this point, down towards the asymptote line, and this graph will go up towards the asymptote line. So that is it for graphing tan functions. Again, important that if its tan is positive, it goes up first, and the second part is down. If it's negative, it goes down, it goes up. Amplitude is always undefined, but a becomes your stretch factor for these middle points. Basically your critical numbers between the start and end and the asymptote. Okay, there's your assignment today. Number 6, they're giving you the graph and they want you to try to find the equation of the graph. So I'll let you try that one on your own, but there's your assignment today, 5 questions. And if you have any questions, feel free to email me.